Welcome to the second to last module of Chem 105. We're continuing to talk about biological molecules, and now we'll be discussing carbohydrates. Key to carbohydrates is the fact that they are individual units that group up to form longer units. The way they link, how many of these individual units link together, and then what the meaning and reason that we want the individual unit delivered is will be a huge part of understanding their main function, which is in getting energy to organisms. That's what we're really focused on with carbohydrates. There are some other functions for sure, as all biological molecules have quite a big degree of flexibility, but the big focus of this course is glucose, the monomer unit, the individual unit, and how it is combined into larger molecules to eventually be delivered somewhere for metabolism. We'll introduce this theme and the different types of other monomer subunits in this first chapter, and we'll continue on through healthcare applications. All right, carbohydrates are often associated with starches and a lot of foods that tend to be tasty, but maybe not thought of as that good for us. In addition to being tasty, they're often kind of blandly flavored and yet universally enjoyed. There's something about our body that seeks out carbohydrates, whether we're little kids or older people. It's not like a real strong flavor that only appeals to some people. These really do tend to be universally regarded as comforting foods. What is it about our bodies that seeks out these comforting foods? And so the main function of carbohydrates is to provide energy to the body. We learned back in our energy chapter that a gram of carbohydrates can be metabolized into 4 kilocalories. And so the reason that they do this is there are a lot of different types of carbohydrates, but they come down to glucose, which is the individual unit of the carbohydrate. And this is the body's primary fuel. Extra glucose is stored in the body as glycogen, which basically if we have a lot of glucose, we can just kind of put a little bit to the side to be used like just a little bit later. It's not like this is long-term storage, but glycogen is what we do with the glucose units. They get linked together to be stored for, this is just how the body has figured out how to do it effectively. And for glucose and other small sugars, they really will look very similar. And if we look at the top right, they're going to have this ring-like structure that'll be closed. They'll have OH groups, and they'll have just carbon and hydrogen otherwise. But these small differences will matter. We'll see some of the other individual units. Glucose is probably the most common one that we'll talk about a lot, but there are a few more as well. And note that in textbooks, you'll often see a linear representation of these monomers that are yet to be linked together into a ring. And I present this here. It's a little bit outside the scope of the course, but one of the significance of this is that where the different OH groups and things are pointing actually does make a difference. And it can come back to this linear representation of glucose, that it forms a different string structure if we unbond the different molecules. Okay, but we really will focus on these ring-like structures, and the long and short of it is that where the groups are placed, and if they're pointing up and down basically, we look at these OH groups on glucose, fructose, galactose, this matters a lot, right? Whether we point them up or point them down, it actually leads to a different molecule. If they're on different sites pointing up or down, that leads to different things, right? These are 3 monomer carbohydrate units, meaning individual building blocks for the larger carbohydrates, we should note. And fructose here is the most different because it only has 5 members of its ring going around. Nevertheless, these are all still carbohydrate individual units, and we may call these monosaccharides, which we can fit into the class of sugars, which are individual and double sugars that we'll look at. In chemistry, repeating units making up larger structures is a huge theme and is something that biological molecules really capture. Carbohydrates is going to illustrate this very strongly. Monosaccharide, this means 1 sugar. Disaccharides means it's a 2 unit sugar, and we could classify the mono and disaccharides both as sugars. A polysaccharide, like a starch, this is many sugars linked together. We can form branches. We'll talk a lot about how polysaccharides fit into this later. But the idea, right, is that we have those individual units. We connect them to make up the class that is the carbohydrate molecules. If we want to break down sort of what there is here, there's a lot more to it than this, but we looked at the monosaccharides, one unit of carbohydrates, glucose, fructose, galactose. When we combine a couple of them together, we can do so in different combinations, right? And even different geometries, as we'll look at in the coming modules. But maltose, sucrose, lactose, these are all disaccharides where we have two monosaccharides that come together. And finally, we have many sugars where we get these large, often branching molecules like starch or glycogen. These are for energy storage for both plants and animals, or I should say for glucose storage for plants and animals. And then fiber is another, complex carbohydrate.